Hi, this is Kristi, and welcome back. Last time we learned how to calculate the slope of lines. To review, calculate the slope of the line drawn on the coordinate plane below. Well, automatically there's one thing that I can tell just from looking at this line. Going from left to right, the line has a downward or negative slope. We talked about lines having negative slopes, or a line could have a positive slope if it was going uphill. So just so I don't forget to put the negative, I'm going to go ahead and do it first. My slope is going to be negative. We talked about finding slope by looking at the change in the y-axis over, I'll do a little formula symbol here. This is change in y over change in x, or you could say figure out the rise over the run. So let's do a starting point of point A. What is our change in y here? And you need to go on a straight line and then turn. You went down 1, 2, 3, 4, 5, 6 blocks over the change in x as I go across the x-axis to get to point B. 1, 2, 3, 4. 6 over 4. Now slope can be reduced. I divide everything in half here and I get 3 over 2. So the slope of this line is negative 3 over 2. Now in this case, you were given a line on a coordinate plane and simply asked to calculate the slope. However, sometimes you will be given only one coordinate and then asked to draw a line with a particular slope. For example, draw a line that goes through point -8, -3, and has a slope of 4. We're only given one point this time. Remember, our definition, though, of a line says it has to have 2 points. So in this case, what you'll need to do is graph your first point and then use your clue here to find a second point. Remember, your coordinates are like this, x, y. So on the x-axis, I need to find -8 first. There it is. And that is going to meet the same time with -3 on the y-axis. Here we go. And that is where they meet. Let's call that point A. I don't have enough information to make my line, but I was told that the slope is 4. If you think about it in rise over run, you have a top number, which is 4. Go back to your knowledge of fractions, and what is the denominator when you have a whole number? It's 1. So my slope then is 4 over 1. So let's rise 4. 1, 2, 3, 4. And let's run 1. 1. So right there is my second point. When you have 2 points, you have enough information to draw your line. So that's just another way that you'll see questions posed to you about lines and slopes. Next page. Now draw a line that goes through point 1, 4 and has a slope of -2 over 3. So this time my slope is negative. My line then needs to look like this, downhill. Find your first point. 1 and 4. Label my axes here so I don't get confused. X is 1. At the same time, y is 4. Here we go. And they'll meet right here. I have my first point. Now, I need to look at my slope for my clue. Rise over run. In this case, if the slope is negative, though, you're not going to rise. You're actually going to drop and then run. That's what the negative tells me. So let's drop 2. 1, 2. And let's run 3. 1, 2, 3. And I have my second point. There. So anytime you have a formula like this for slope written in rise over run, the negative is going to apply to the top number. Sometimes students will say, well, since it's negative, don't I have to run to the left? No, it only applies to the top number here. You either rise or you fall. Run is always to the right. Excellent. Today, we are going to bring algebra back to our lesson. I know you were wondering when we were going to get to that. Here it is. We're going to see how lines can be represented by equations. These are called linear equations. You can see right there. Line is the root of that word, linear equations. A linear equation that has a defined slope other than 0 will be written using two variables, usually an x and a y. Previously, we've mostly worked just with formulas that have an x. This is logical since our coordinate plane has both an x and a y-axis. A linear equation can have the variables on either side of the equation like so. See, I've got a y on this side, an x on the right. Here they're both on the same side of the equals. Here I've got an x on the left, a y on the right. So these are actually all equations for lines. Y equals 1/2 x plus 3. 2x plus 2y equals 10. X equals 2y minus 7. This is even a line. I said that you will usually see an x and a y in your linear equation, but you can occasionally see something different. In this case, it's 3a plus b equals 6. Now stick with me here. Next page. However, this is not a line. X squared plus 3 equals y squared. Well, I said it could have an x and a y on either side, so what's wrong with this one? What is different about this equation? Hopefully you looked over here and you saw that your variables were raised to power. X squared plus 3 equals y squared. So those are not lines. They're actually something different, which maybe someday you'll study. So let's fill in the blank here. A linear equation must have the variables raised to the power of blank. If the variables are raised to any other power, it is not a line. So basically, it could be something that looks like this. It could be something that looks like this. There are a lot of different options that you can put onto a coordinate plane, but we're only talking about lines in this class. And to have a line, the variables must be raised to the power of 1. If the variables are raised to any other power, it is not a line. So even though linear equations can be written in several different ways, it's helpful if the y is on the left side of the equation, on the left side of the equal sign by itself. Y equals 2x plus 3. When you see a line written this way with the y on the left and then the x on the right and then an extra number here, it's called the Slope-Intercept Form, and it's the most common way to see a line written. Why? Well, because it makes our algebra lives easier. You can tell the slope and where the line intercepts or crosses the y-axis just by looking at the equation. So up here, these numbers 2 and 3 are actually giving you hints about the line. The 2 is actually the number for slope. The slope of this line is 2. And the 3 is actually where our line crosses the y-axis. So you will see slope-intercept formula written like this. Y equals mx plus b. That's just a famous formula for lines. The slope will be the number next to the x. In this case, it's just the purple m here. That could be, say, a 2 like we had above. And the y-intercept will always be this loose number here on the far right. It could be a plus and then a number, or it could be a negative and then a number. If it's negative, you have to keep that with the number. Now, isn't this cool, though? Now we can graph a line without being given even a single coordinate. Next page. So let's practice this formula. Let's graph the line with the equation y equals 2/3 x plus 2. Well, first I want to go back and make sure that this is written in slope-intercept form. Here we go. We said that slope-intercept form would have the y all by itself on the left, and it does. Then it's going to have some number next to my x, and it does. And then it's going to have a loose number on the end, +2, and it does. So this is slope-intercept form. It should be easy to graph this. And for the first one, I put the steps here for you so you can refer to them later. Plot the y-intercept, which is the last number on the right. There it is. The y-intercept is +2. So here's your x-axis, here's your y-axis. All you need to do to find your first point is look for the y-intercept at 2, and there it is. That's where my line is going to cross the y-axis. What I don't know, though, is which way my line is going to go. It could be like this. You see how I'm keeping that point on my ruler each time? What I need is to figure out my slope. My line could be any of these. So let's figure it out. Number 2, the number attached to the x will tell you the slope. Here it is. The slope is 2/3, or 2/3. Then use your knowledge of rise over run to find a second point. Okay, we just did this on the other page. So rise, or change in y, over run, or change in x. We're going to go up 2 and over 3. 1, 2, 1, 2, 3. There's my second point. Number 3, draw the line that connects the 2 points. There we go. So we just drew the line that represents y equals 2/3 x plus 2. I think that's kind of nice. When you see the formula that way, you're automatically given the slope and the y-intercept, and it's fairly easy to graph the line. All right, let's do another one. Use the same procedure as we just did to graph the line y equals -4/5x plus 1. So look very carefully. Does this look like the line is in slope-intercept form? Well, y is by itself on the left, and I have some number stuck to my x, and then my loose number. Do we know the slope? -4/5. So we're going to have a downward running line. The y-intercept, +1. Now, following our steps up above, we're supposed to plot the y-intercept first, which is the last number on the right, +1. See how easy it was to get my first point? Now look for your slope, which we said was -4/5. That means negative, it's going to drop 4, and then it's going to run 5. Let's drop 4. 1, 2, 3, 4. And go over 5. 1, 2, 3, 4, 5. And there's my second point. The last step was to connect the 2 points together. And remember to put your arrows on the end to show that it's a line. We just graphed the line y equals -4/5 x plus 1. Excellent. Next page. Now you won't always see a line written in slope-intercept form. You knew this was coming, right? It would be nice and convenient if lines were always written like that. So you should know how to put a linear equation into slope-intercept form. It's not that difficult to do. Look at the linear equation below. Doesn't it appear as if the 9 is on the wrong side? If you want it in slope-intercept form like this, the y needs to be by itself on one side. So how can we get y by itself on one side? What's in our way? This piece here needs to move over, doesn't it? Do you remember how to move a number or a variable to a different side of the equation? Here we're going back to algebra. I hope you do remember. You're going to do an opposite operation to each side of the equation. You can't just move this all by itself, right? You can't just move things whenever you want. You've got to strategically think about it. So if I have a plus 9 on one side, then the opposite operation is a negative 9. Subtract 9 on this side. And remember, what you do to the left, you must do to the right. So subtract 9 from the right side. This is going to allow these to cancel, negative 9 and plus 9. And now, suddenly, I'm left with just y by itself on the left of the equal sign. On the right side, rather than having just 6x, I now have 6x minus 9. So I moved my plus 9 to the other side. Some people think of it as change the sign and just move it. It's the exact same thing. Now here's my formula in slope-intercept form. Let's just double check it. Do I have y by itself on one side? I do. I have some number next to my x. This will be my slope here. And then I have a negative 9, which is my y-intercept. So with one step, I was able to put my line into slope-intercept form. So what would be the slope of the line? This one here. The number stuck to the x, or you could consider it to be the m in the formula. Y equals mx plus b. That is the slope, 6. What is the y-intercept? It's the 9, but don't forget to bring the negative with it. Negative 9. All right, now practice graphing. Graph the line y plus 3 equals 1/2 x. Remember to rearrange the terms to get the y on the left by itself. Okay, now there are other ways to graph this line, but the easiest way is to force it back into slope-intercept form. At this point, I want to get rid of my plus 3 there, don't I? I want y by itself on the left. If I subtract 3 from each side, that will allow me to get rid of my plus 3, because plus 3 and minus 3 become 0. Now on the left, I have y by itself equals, go ahead and keep your 1/2 x. And what's over here with it now? Minus 3. So suddenly, you've put it into slope-intercept form. Now it'll be easy to graph it. What is your slope? It's this number right stuck to the x here, 1/2. And your y-intercept, don't forget to grab the sign, but it's right there, negative 3. So start with your first point. Are you wondering where your first point is? It's right here, the y-intercept. You know where the line crosses this coordinate plane here. It goes right here at negative 3. That is your first point. If you were to give a coordinate for that, it would be at x is 0 and y is negative 3. So it really is a point. We just haven't shown it like this. We just said y-intercept is negative 3, and you know where it is. Now the slope is 1/2. That means it's rising 1 and running 2. Let's do that. Rise 1 and run 2. There's my next point. A little tight here, but that's okay. In fact, you can keep on going if you want to make it easier. Rise 1, run 2. Now you've got 3 points. Make sure our line is exactly right. You could keep on going and make as many points as you want. Put your arrows on the end. And there's the line. This is the line y equals 1/2 x minus 3. Very good. Next page. We're almost done. Now graph the line y minus 5 equals 3x. Why don't you go ahead and pause the video here and start again when you've completed these two. Okay, back together again. Hopefully you figured out that you need the y by itself on the left and that this negative 5 here was in your way. How do we get rid of a number on one side of an equation? Do the opposite on each side. The opposite of subtracting 5 is adding 5. Make sure you do the same thing to each side. That's allowed. Now my plus 5 and my negative 5 cancel out. On my left side, all I've got is y. On the right side of the equal sign, I have 3x, which never moved. Now I've got to add my plus 5. That's my equation for the line, y equals 3x plus 5, and it's in the form that I want to see it in now. Now the slope is right next to the x, which is 3. My y-intercept is over here at positive 5. So same thing we just did. Let's find the y-intercept first. Positive 5, that's our first point. And our slope is 3, so we know it's going to be going up. We're going to have an uphill line here. But I don't know what the run is. I see the rise is 3. Remember, when you have a whole number, it's the same thing as putting 1 in the denominator. So then it's going to go up 3. That's my rise. My run is over 1. 1, 2, 3, 1. There's my second point. Connect your points, add your arrows, and you're done. This is the line y equals 3x plus 5. And it's also the line y minus 5 equals 3x. It's the same thing. Last one. Graph the line 2 plus y equals negative 2/3 x. Well, this time you see a number kind of over here on the left. That's different. It doesn't matter. It's the same thing. We want to leave y by itself on the left of the equal sign, and here I have a positive 2. Let's do the opposite operation, which is to subtract 2 on both sides. Plus 2 and negative 2 cancel out. I'm left with y by itself on the left equals negative 2/3 x, and it's going to be minus 2. All right, got a lot of negatives here. So then our slope, negative 2 over 3. This time I'm going to drop 2 because it's negative and run 3. Y-intercept here, negative 2. Well, to graph a line, we need 2 points. I don't see 2 points, but I actually do see one. Here it is, the y-intercept at negative 2. This is my y-axis. Here's negative 2. That's my first point. To get my second point, use your slope as your clue and drop 2 and run 3. 1, 2, 1, 2, 3. There we go. And connect your 2 points to make a line. This was the line y equals negative 2/3 x minus 2. Okay, excellent job today. I hope you learned a little bit more about drawing lines and slope.